Good day everyone. So in this video presentation, I'll be sharing with you my task in Calculus Video Challenge, Share Your Insights in Calculus 1. So we have 4 topics in here: implicit differentiation, higher order derivatives, maxima and minima, and time rates. So first, let us define calculus. Calculus is a branch of mathematics that studies the rate of change. It is used to model systems where there is change. These models can be used to see what the effect of change on one aspect of a system. So examples of the application of calculus in scientific fields are space exploration, telecommunication systems, computer science, engineering, medicine, pharmacology, business, meteorology, and music. So we will be discussing first the implicit differentiation. Implicit differentiation is the procedure of differentiating an implicit equation with respect to the desired variable x while treating the other variables as unspecified functions of x. So it is particularly useful when dealing with equations where it is not straightforward to express y explicitly in terms of x. It is commonly applied in problems involving curves, circles, and implicit functions. So d over dx times y minus y raised to 1 half. So nahimo na siyang y raised to 1 half diri because gitake na to ang ihang square root. Then we derive the next equation, which is d over dx times ln times x. So mahimo na siyang dy over dx negative 1 half times y raised to negative 1 half. And then the other equation nga nahimo ng dy over dx equals 1 half. Then following the operations, dy over dx 1 minus 1 half times y raised to negative 1 half equals 1x. dy over dx 1 minus 1 over 2 square root of y equals 1x. So, ato ang i-transfer ang 1x, so mahimo siyang 1x times 2 square root of y over 2 square root of y minus 1. So, to find dy over dx, we need to cancel like terms. So, mahimo siyang dy over dx 2 square root of y minus 1 over 2 square root of y all over 2 square root of y minus 1 over c equals 1 over x all over 2 square root of y minus 1 over 2 square root of y. So, naay pareha nga term diriya and we need to cancel them to get dy over dx. So, the result will be dy over dx equals 2 square root of y over 2x square root of y minus x. So that is the answer. So that problem, ma-apply siya sa real world because that approach is essential for understanding and modeling complex systems where certain variables are interrelated. Solving equations implicitly allows us to capture intricate dependencies that might not be easily apparent, providing valuable insights for scientific and engineering applications. Next is higher order derivatives. So higher order derivatives refers to the repeated process of taking derivatives of derivatives. Higher order derivatives are applied to sketch curves, motion problems, and other applications. It is the successive derivatives of a function with respect to the same independent variable. In calculus, the first derivative represents the rate of change of a function, and higher order derivatives extend this concept to capture information about the rate of change of the rate of change and so on. So if y is equal to f times x, then the first derivative is denoted as dy over dx or f prime times x. So here is our problem. F times x equals 2x minus 5 raised to 2. So we need to determine the general formula for f raised to n times x. So solution. f prime times x equals 2 times 2x minus 5 d over dx 2x minus 5. So, ato ang i-differentiate ang function nga gihatag. So, mahimo siyang 2 times 2x minus 5 times 2. So, 2 is from the exponent and the other 2 nga nasa pika side is the derivative of the equation 2x minus 5. X is, mahimo na siyang 4 because of 2 times 2. Then, need to multiply 2x minus 5 to 4. So, it will result to 8x minus 20. So, that is our first derivative. So, the same process that we use in getting the first derivative, next is ang second derivative. So, it is the derivative of the first derivative. So, the same process, makakome up ta og result of 8. In getting the third derivative, which is the derivative of the second derivative, we know that 8 is constant in differentiating. So, mahimo siyang 0 because this is constant. The same with the fourth derivative, 0 gihapon ang iyahang result. So, this is how we can relate the higher derivatives in the real world. In physics, the first derivative represents a velocity. The second derivative represents acceleration. The third derivative represents jerk or rate of change of acceleration. Understanding these derivatives is crucial in describing the motion of objects. In engineering, derivatives are used to analyze and design systems, such as in control theory. For example, is the second derivative can indicate the stability of a system. In finance, derivatives play a role in calculating rates of return and risk assessments. The concepts of derivatives are fundamental in various fields, and their applications extend to diverse domains where understanding rate of change is essential. Our third topic is maxima and minima. So we define maxima and minima, the maximum or the minimum range value of a function within the given set of ranges. For the function, under the entire range, the maximum value of the function is known as the absolute maxima, and the minimum value is known as the absolute minima. So understanding maxima and minima is crucial in optimization problems, where the goal is often to find the maximum or minimum value of a certain quantity. Study of maxima and minima is an essential part of calculus and has applications in various fields such as economics, physics, engineering, and computer science. So our problem here is a normal window is in the shape of a rectangle surmounted by a semicircle. What is the ratio of the width of the rectangle to the total height so that it will yield a window admitting the most light for a given perimeter? So solution, let P equals perimeter, P equals 2x plus 2y plus 1 half times 2 times pi times x. P is equal to 2x plus 2y plus pi times x. So, 2y over 2 is equal to P minus 2x minus pi times x over 2. So, y is equal to P minus x minus pi times x over 2. Mag-equal siya into 0.5p minus 2.57x. So, mo na siya nga itong equation 1. So, daghan ta diri og mga formula. For example, the area of the window, A equals 2xy plus 1 half times n times x squared. Mo na siya nga itong equation 2. Third formula is for the height. H equals y plus x. Formula for the volume of the cylinder. V equals pi over 4 d squared times h. Substitute equation 1 in equation 2. A equals 2x times 0.5p minus 2.57x plus 1 half times pi times x squared. Nihimo siyang A equals px minus 5.14x squared plus pi over 2 times x squared. So, A will be equal to px minus 3.57x squared. So, we need to find the d over dx here. D over dx, px minus 3.57x squared equals p times 1 minus 3.57 times 2x squared minus 1. So, the dA over dx, it is equal to p minus 7.14 equals 0. So, atong balihon, 0 equals p minus 7.14x, then x will be equal to 0.14p. So, substitute x in equation 1. Ingani iyang format. Y equals 0.5p minus 2.57 times 0.14p. Y equals 0.5p minus 0.3598p. So, y will be equal to 0.14p. So, this format is gikan siya sa mga formula nga ako ang giingon kagaina nga naa diri a. So, substitute for the h. H equals y plus x. H is equal to 0.14 plus 0.14, and we all know that it will result to 0.28. So, to solve for the ratio is equal to 2x over h equals 2 times 0.14p over 0.28. So, ang answer overall is 1. This is how maxima and minima relate to the real world. This optimization problem is relevant. Finding the optimal ratio of width to height for a window can influence the design of buildings, particularly in maximizing natural light with adhering to certain constraints such as the perimeter of the window. This is crucial for energy efficiency, as buildings with well-designed windows can reduce the need for artificial lighting and heating, contributing sustainable and environmentally conscious construction practices. In essence, finding maxima and minima in the real world helps us make decisions to optimize outcomes. It could involve maximizing profits, minimizing costs, optimizing resources, or achieving the most favorable conditions. Calculus, particularly the study of derivatives and critical points, provides the tools to analyze these situations and find the best possible solutions in various fields and industries. Our last topic is time rates. So, time rates can be solved by differentiating. It is a worded problem in differential calculus. One variable is given or solved with respect to time. Time rates in calculus involve understanding how quantities change over time. Derivatives provide a powerful tool for analyzing and quantifying these changes, whether it's the instantaneous rate of change, average rate of change, or the interrelation between rates of change of different variables. These concepts are widely applied in physics, engineering, economics, and various other fields to model and understand dynamic processes. So the example of time rates is car A moves due east at 30 km per hour. At the same distance, car B is moving south 30° east with a speed of 60 km per hour. The distance from A to B is 30 kilometers. Find how fast is the distance between them separating after 1 hour. Solution: solve for S using cosine law. So C squared equals A squared plus B squared minus 2 times A times B times cosine times C. So S squared equals 30t raised to 2 plus 60t minus 30t squared minus 2 times 30t times 60t minus 30 times cos times 60. So, following the operations, s squared equals 900t squared plus 60t minus 30 squared minus 2 times 30t times 60t minus 30 over 2. So, atua lang i-follow ang mga operation. So, s squared equals 900t squared plus 60t minus 30 squared minus 30 times 60t minus 30. So, d over dt, s squared equals 900t squared plus 60t minus 30 squared minus 30t times 60t minus 30. So, 2s ds over dt equals 1,900t plus 2 times 60t minus 30 times 60 minus 30t times 60 plus 60t minus 30 times 30. So, ato alang i-subtract or i-times or i-plus. ds over dt equals 100 ds over dt equals 1,800t plus 2 times 60t minus 30 times 60 minus 180t minus 30 times 60t minus 30 over 2s. So, ds over dt equals 120 times 60t minus 30 minus 30 times 60t minus 30 over 2s. It will be ds over dt equals 3,600t minus 900 equals 2s. So, this is s when t equals 1 second. S squared equals 900 times 1 squared plus 1 minus 30 squared minus 30 times 1 times 60 times 1 minus 30. Mag-result siya into 30 kilometers. So, to find ds over dt, we will substitute ds over dt equals 3,600 times 1 minus 900 over 2 times 30, and it will result to 45 km per hour. So, that is the answer sa ato ang problem here sa time rates. So, we can apply time rates in the real world because this type of problem is relevant in traffic engineering, logistics, and transportation planning. Understanding how the distance between moving entities changes over time is crucial for optimizing routes, managing traffic flow, and ensuring efficient and safe transportation systems. Similar principles apply in various fields, including robotics, where the motion of multiple objects needs to be coordinated. So, applying time rates in the real world involves using calculus to analyze and understand how quantities change over time. This has numerous applications across different fields, and here are the examples. Physics in motion and velocity. Economics for revenue and cost. Biology for population growth. Engineering for heat transfer. Chemistry for reaction rates. Finance for investment growth, and meteorology for weather changes. In each of those examples, calculus and the concept of rates with respect to time provide a powerful framework for analyzing dynamic systems and making predictions or decisions based on how quantities changes over time.